Good day, and welcome to this webinar from Solace on the microservices in practice. Joining us today is one of our favorite presenters, Jonathan Schabowsky, who is the Senior Architect for the Office of the CTO here at Solace. And we'll be discussing event-driven architectures and microservices and how you can improve all kinds of data flow inside of those. With that, let's get started because I know Jonathan's got a lot to talk about. And Jonathan, welcome to our webinar.
Hey everyone, thanks for being able to join. So again, I'm Jonathan Schabowsky, and one of my primary initiatives here at Solace is to promote the practice of microservices and sort of all the surrounding technologies that really enables them from a technology perspective. So some of you may have remembered that we started this series back in May and discussed some misconceptions around microservices and explained how running them in a platform as a service such as Pivotal Cloud Foundry provides some real benefits. So today I want to further that discussion from an architectural and design perspective. So let's go ahead and jump in. From an agenda perspective, we're going to start off with a quick review of my thoughts around what microservices are and how REST and HTTP became synonymous with microservices. Much of this is going to be pretty brief. We presented this, like I mentioned before, back in May. So we're going to kind of breeze through that, but it kind of sets up the rest of the discussion and provides a little bit of direction. We'll then talk about microservice interaction styles and how event-driven architecture, when combined with microservices, provides some real advantages. And then we get to the fun part, in my opinion. We'll dive into a reference architecture we created and see how these patterns actually could work in practice. So let's start with the biggest question of them all. What are microservices? So when I started looking into this, I realized that there was really no industry-accepted definition. So in my mind, there were generally 4 widely accepted attributes of microservices. The first being single in size and small in purpose. And I would say that this is probably one of the most important attributes of microservice. The main point here is that you need to make your services small enough such that they really only perform one task. So this in of itself means that individual tasks can scale as effectively as possible, and ultimately your teams can sort of separate up and build their own little microservices that can all be orchestrated in order to provide real business value. And kind of back in the days of SOA, it was really common to create these mega services that combined many operations. And it turned out that was really bad practice, as you couldn't independently scale the methods being invoked frequently. Multiple teams were all trying to work on the service at the same time. It really wasn't a great pattern. So the next attribute of microservices is that they need to be able to be independently deployable. So this not only allows for independent scale, but also enables a much more simplified deployment that can occur at a faster rate. And a lot of companies that we talk to in areas of industry have really adopted this methodology of code in the morning and deploy into production at the end of the day. So it kind of goes without saying that this whole microservices architecture would really never work if services weren't independently deployable. And in that same vein, the code is going to be deployed very frequently. And so being released via an automated process can be an overlooked aspect, but is certainly very key. Last but certainly not least is communicate using technology-agnostic protocols. And this is going to be, again, one of the major focus areas of our discussions today, mainly from the aspect of since microservices have to be small in size and single in purpose, they do need to be able to communicate. They need to be able to be orchestrated to provide that business value. And obviously that means communication. So when you really start researching microservices and you listen to a lot of the different talks and go to conferences, and a lot of people are really just still focused around the use of HTTP and REST for that communication between microservices. And it certainly has its place. And I believe that the reason this mechanism has become so popular is that HTTP is the transport that makes the internet work. And all developers are really, really familiar with it and frequently use REST. REST naturally took the HTTP protocol and standardized its usage based on the HTTP operations and URL resources. And it makes a lot of sense and is way better than what we had kind of back in the SOA days with just SOAP web services. Next is, request response is certainly a natural way to think. In our daily interactions, whether it be with people or technology, we think of asking questions and having them answered. Most of the programming languages have sets of libraries, which are synchronous request reply. And I don't know, as a developer, we feel really comfortable with that pattern. But the key is that there are other forms of communications that we really need to discuss, and that's, again, a big part of what this webinar is going to focus on. And then, of course, works like a web browser and is certainly a better alternative to traditional SOA and SOAP-based web services. So one of my favorite sayings is that, when holding a hammer, everything looks like a nail. And so, from the aspect of that analogy, REST has become a hammer, and certainly not everything is a nail. So I showed this in the last webinar, but certainly this icon graphic here of the hammer kind of beating into a screw drives home that point. So ultimately, REST is really good for synchronous interactions as well as externally facing APIs. Again, there's no doubt that without REST, without the ability for them to be consumed by a variety of different languages, the support of the different firewalls, and from a security perspective, there's no doubt that there would not nearly be the amount of technological evolution that we've seen without REST. But at the same time, it does bring along some baggage, and as we discussed previously, the aspects of blocking, service coupling, and complex failure scenarios, and ultimately the responsibility for those failure scenarios becomes sort of I don't want to say a death nail, but a little bit of a problem, at least, if you were to purely build your microservices architecture based only on REST. So now as we kind of move into the new material after kind of reviewing that, one of the key areas that we found when talking to a lot of our customers is, where does REST fit versus where does messaging fit? And ultimately, so we created this picture kind of showing a traditional architecture that most enterprises would have where basically interaction either starts at a web interface or maybe it starts somehow through a mainframe or system of record. So if you're coming in from the web aspect, you're going to access the system usually through some sort of a security gateway. So that's going to perform your identity and access management. It's going to perform your API management. And then you're going to find yourselves typically into a web application that's backed by microservices to do that back-end style processing. A lot of the data and sort of insights generated out of that microservices architecture could flow into a data lake for analytics. Monitoring is certainly a critical aspect of any system, the ability to monitor all of these functional components and make sure everything's performing as necessary. And then, the key here is that, REST works really good from the web UI interface into that front-end processing, but then that's, after that, messaging is a really good tool to have. Again, sure, you might be able to intermix REST across these other boundaries where I have messaging, but the key is messaging really provides a lot of these different interaction styles that really help your system architecture. And of course, I work for Solace, so a little bit of a shameless plug on having Solace messaging in our VMR graphic on this slide. So when I talk about the different interaction styles that really ease enterprise architecture, what I'm really trying to say here is that REST is an inherently synchronous protocol because HTTP is. And so because of that, the HTTP REST protocol really supports this synchronous and sort of one-to-one message exchange type pattern, whereas messaging is more of an inherently asynchronous interaction style that supports, publish and subscribe, request multi-response, request asynchronous response, all while still supporting request reply. And, there's a lot of advantages by making use of messaging And we'll talk about that. And I also kind of want to mention here that I'm not saying that there aren't frameworks in industry being used today and successfully that make use of HTTP and REST in order to make it appear more asynchronous. But I think one of the keys here is that they're kind of already implementing what messaging has had for many, many years, and they're typically less robust. For instance, they wouldn't provide sort of a guaranteed delivery mechanism, and they're gonna do it in a less performance sort of way. So when kind of looking out there of how you want what interaction styles you want your microservices to communicate with, be a little bit leery of some of the frameworks out there that are just wrappers basically of HTTP and REST that provide those asynchronous sort of styles. So CQRS has become very, very popular today. And when I started reading about CQS and starting to kind of use it in practice, one of the things that became kind of obvious to me is that there's many aspects in a microservice where you're going to have to query for additional pieces of data. It's hard to avoid the need for being able to do query. There's a couple of patterns out there that can sort of help with that, but regardless, in a lot of cases, you're going to have to query for additional pieces of data. But what I don't like is the word command, because that essentially, if one microservice is commanding another microservice to take some action, that is essentially right there introducing some amount of coupling. And so if we start to think about commands in a slightly different way, start thinking about more commands are really just events. And if a microservice produces an event, it's up to a downstream service to interpret that event and take action on it if necessary. So in that particular case, the microservice is really just sending out an event saying that some important event has occurred, and really the downstream service can take action depending on the business case. So that's one aspect here related to kind of the CQRS command query style interactions that's very useful to keep in mind, because the more that the client needs to handle response failures, they need to be able to wait, they have to know how long to wait. All of these sort of aspects all are adding logic to the invoking microservice, and that logic has nothing to do with really its core function, that single and purpose aspect. It's actually all dealing with its need to have responsibility over error scenarios that are happening downstream, and ultimately that leads to tight coupling. So a great solution, and I've already hinted at it, and I talked about it a bit last time as well, is to use event-driven microservices. So by making use of asynchronous interactions such as publish and subscribe, it really provides a much, much more powerful tool than what just REST and HTTP provides out of the box. So in many cases, asynchronous is really just a better way to think. Most of the communication mediums that we use are asynchronous. So think of email or text messaging, etc. So that kind of proves in a way that publish and subscribe is really used in real life, on Facebook, on Twitter, on LinkedIn, and the amount of time that it saves you by only seeing the updates that that people have really put on there is such a time savings, and would be a waste to do it any other way. And so with services being more decoupled, these events can also be consumed, 0 or many times by other microservices or applications, each with their own unique job. So if we think about e-commerce, where the mission is to allow a widget to get purchased, once the order is received, it needs to go to billing and collect the money, then off to inventory, then to shipping. It seems simple enough, but what happens if you want to inject fraud detection in before billing, or you want to add analytics engine to predict buying trends for inventory management? You want to be able to add those new features and functions in without rewriting your services, as ultimately they shouldn't care. They're still, the microservices that are existing in the architecture, they're still doing the job that they always did. You're just now enhancing and providing additional features and functionality. Additional added benefit of messaging is that it's easy for monitoring systems to look at if queues are backing up or consumers are going offline or not sending messages. And sometimes messaging can really be sort of the canary in the coal mine to show us potential problems before they occur. Significantly as well, messaging adds a lot of resiliency to off-nominal scenarios such as downstream processing failures. Services that are up can continue accepting requests, providing that data out, publishing their outputs, and once that initial error condition has been fixed, those services can scale up, get the work done that they missed, and ultimately have the enterprise go back to the nominal operating state. Also, disaster recovery could be configured to where you could fail over easily to a completely different site while never losing any of the in-flight data. And so when you start thinking about the resiliency, you start thinking about these disaster recovery type features, it would be pretty horrible to sort of have to add all of those kind of logic pieces to each microservice in order to have continuity of operations when failures occur. And then finally, certainly developers can create and update service code much more easy due to the loose coupling, and they can have confidence that there won't be impact to operations during deployment because really, again, they're loosely coupled. You can deploy your new microservice. It's now receiving events. It didn't really have any impact on existing services that are out there, which is a great benefit. So as I've gone through and talked to a lot of companies, certainly over the last 6 months, about their microservices architectures, talked to them about how event-driven architecture can really help them. A lot of benefits are pretty easy to see that we've already talked about. But there are some challenges that we've uncovered as well. The first being that, kind of mentioned before, request reply is a really natural way to think in that asynchronous and sort of publish and subscribe, a lot of those kind of patterns, people don't just right off the bat think about. So it's not natural to them, and ultimately the architects and developers, they really need a little bit of education. They need a lot of examples of how this is actually used in industry in order for their thought processes to change so that they naturally start architecting in that event-driven sort of way. Second is correlation. Because of the asynchronous aspect, services may need the ability to correlate different events together because they did occur asynchronously. And the third piece I don't have as a bullet here, but it is important, and we actually, in our reference architecture, talk a little bit about this, is the aspect for needing eventual consistency as part of event-driven architecture. So because we really don't have a mechanism to do ACID transactions, we certainly don't want to do distributed transactions or two-phase commits. You really have to make use of eventual consistency and get used to sort of the aspects that the benefits and sort of some of the downfalls that can bring. So when I was sort of setting out to really start creating my own little microservices architecture, I really spent a lot of time thinking, if I could create the perfect architecture, what would it have? And these are sort of the 5 main things that I wanted it to have. I wanted it to be scalable, and I really didn't want it to dictate how the different mechanisms of scalability. I knew I wanted to have horizontal scalability and scale up each individual service in order to meet demand. The ability to have dynamic scaling, especially if you've got a domain that where load varies significantly. For instance, if you're an e-commerce site and you have some hot new product that's going to hit the market and you have tons of people basically lining up on your website for that to be released, the ability to do dynamic scaling is critical in order to meet the demand, but also not be eaten by costs and scale down when you go back to that normal load. And that also has to deal with shock absorption. A lot of systems have proven that they fail when you have that irregular burst of utilization. And so by being able to have shock absorption capability built into the architecture, I felt like that was really going to be key. Second, of course, we need fault tolerance. I don't think anyone wouldn't want that. And oh yeah, we have a failure, so let's just have the whole system catch on fire. No, I don't think any of us want that. So that kind of goes without saying. Certainly, performance is key, and being sort of more performant than traditional microservices architecture. I felt like would be a powerful aspect. And then finally, manageable and secure. Certainly, especially as more and more organizations are going to public clouds, they're realizing all the intricacies around the communication aspects of, for instance, if you're in a healthcare domain and you have HIPAA requirements, all of your traffic within AWS has to be encrypted. So that can really be a real nightmare if you have a whole lot of services that all need to talk. So trying to find ways to alleviate those kind of problems was a key aspect. So one of the most common discussions we get into with our customers, however, is they're really working to undergo this digital transformation model, and microservices and event-driven architecture are becoming key to that. One of our customers, for instance, was saying that they were trying to build some new capabilities, and they have a lot of mainframe applications today. And so they had basically scoped out that the cost of doing the work within a microservices architecture would be, say $250K in labor. But in order to mess with the mainframe and deal with the dependencies and thoroughly test against existing applications, that it was going to be a $2 million cost. So that's why a lot of organizations are saying, well, if we could basically scrape events out of our mainframe or our systems of record, really stream them into a microservices architecture and really feed those applications with data, that would be key, because they can provide that functionality in a much quicker and much less expensive sort of way. And so what we've done here is we've sort of broken up the interactions here into there's an event store, there's a microservices EDA app area, and then the number 3 there is signifying that data that's kind of crunched on by the microservices ultimately has to be, in many cases, delivered to external customers, partners, etc. And that really all of these are really sort of messaging use cases. And so if you can have a unified messaging architecture that's kind of dealing with all 3 of these key aspects, that certainly allows for less integration time and quicker development for the applications themselves. All right, so now on to the fun part of this talk. So ultimately, what we decided to do at Solace is really eat our own dog food a little bit and create an architecture that is easy to understand for people that are listening to a webinar or one of our presentations, but shows the power behind making more event-driven architectures. So we created a fictitious problem, though I think it is a real problem many of us struggle with. Is have we all been at parties and kind of wish somebody would come and replenish the supply of beer, wine, or liquor? So we created a solution that we're calling a Sol Beer, so Solace Beer Store. And so it's kind of the Uber of beer, if you will. So it's take Amazon and take Uber, combine them together. So it's an e-commerce site for basically ordering beers, such that you could actually track your order and have your choice of beverage within minutes. So, and again, the key was to prove out a lot of the common use case challenges that you really encounter when you're creating a microservices architecture. And certainly an e-commerce application will have a lot of those challenges. And then obviously by laying that on top of beer, it at least makes it hopefully a little bit interesting. So when we kind of, we all start at the high level from an architecture perspective, and we decide what components do we really need to have in order to solve this problem. Certainly we need a customer. So a customer needing beer, particularly one that's maybe in the desert, apparently. That's the key user that we need to ensure is happy. They would access our system via our web application. And then there's some back-end services that are certainly needed. An inventory manager that's going to keep track of what beers are in stock, how many are in stock, which are reserved pending delivery, all of those kind of aspects. everything related to inventory. We certainly want to get paid, so having a billing service that deals with the credit card providers and ensures that that we get paid is necessary. And then the logistics, getting the packaging, finding a delivery vehicle, is all basically part of this little microservices reference architecture. And so if we did this all with synchronous communication, which again, I see this at a lot of organizations. They say, okay, well, all of these boxes are basically microservices, and I'm just going to use REST in order to communicate. So essentially, the customer places its order through the Solbeer web app. So the next thing that happens is the inventory manager would reserve that order. Billing would go and charge the credit card. Once that's all good, logistics would go out, search for the delivery vehicles, talking to each one, and then ultimately, and I jumped ahead. Once logistics would though find a delivery vehicle, it would tell the inventory manager that essentially that order is no longer just reserved; it's actually committed. And so there's some issues with this architecture that become a little bit more apparent if you take that and actually kind of build it into a sequence diagram. So as you can see again here, the user is going to order some St. Ambrose. I had to put that in there since Solace is a Canadian company, even though I'm not Canadian. So that would ultimately hit the web app. Inventory manager would reserve the product. The web app, again, calls billing. So you can see the activity that all happens within this life cycle of the web application. The time is completely dependent upon all the downstream services. So that's certainly one problem. Another problem is that this basically is using purely just a bunch of command and query interaction. So for instance, inventory manager is telling logistics to find a car. The web app is telling the inventory manager to build a credit card, etc. So that's probably not a great idea. As I mentioned before, the response time of the web application, which really goes back to the user experience, could be significantly degraded if any one of these services acts a little bit slow. And really, logistics kind of has a bit of a problem here of, well, how does it even find all the delivery vehicles? These delivery vehicles are sort of running outside of the microservices architecture, so understanding where they are from an addressable perspective is certainly a big challenge. And I think one of the biggest problems with this is that this web app really became an orchestration manager for the overall enterprise. It knew that first it had to go to the inventory manager, it then had to go to billing, and then it had to go to logistics. And the fact that the web app has all of that logic also means if you were to add, for instance, fraud detection in before billing, you would actually have to edit the web application or edit billing to add that kind of capability, and that seems pretty unnecessary to me. So the last one was tight coupling surrounding, should the inventory manager even really know about logistics? Should it know that it's really looking for a car versus basically the inventory has just been reserved? Again, I don't think that there should be a lot of this tight coupling that this architecture would have. And so what we did then is we said, okay, well, the components all remain the same, but can we decouple this architecture in a much more simple way? So the consumer, of course, still needs beer, still is going to place an order through the beer store web app, and then it sends out an event through messaging that essentially just says, an order's been placed. The inventory manager piece would pick up that event to reserve the order and would basically respond back, and boom, the consumer now knows that its order is pending. And then what's really useful here is that everything in this orange box is basically deferred execution. And what that really means is that in the life cycle of that user kind of waiting for his order to initially be processed and get that response back that the order is pending or in process, all of these aspects can actually occur downstream as long as you have compensating logic for, if billing fails, the customer is going to want to know that the billing failed, so use email. You actually see this a lot of times in Amazon, where you almost instantly get back that your order's been placed, but then you could get an email downstream saying there's actually been some hiccup with the order. They're doing deferred execution, and what's really unique about that is that this architecture much more robustly supports shock absorption. So let's say something crazy happens, not that I think it ever would, but there's a rush on Budweiser. And so there's a whole bunch of customers lined up to place their order for that. Well, instead of having to scale all of the services for that peak load, you really only need to scale up your web application and your inventory manager to handle the peak load. And then ultimately, behind the scenes, these the billing, the logistics, and the delivery vehicle aspects, they really can be kept at sort of average scale, and that saves a lot of cost and provides a more robust fault-tolerant architecture. So another unique piece of this architecture is, I mentioned before that the web app, when it was all synchronous communication, the web app really became an orchestration manager, or even really almost more of a choreographer. And certainly back in the SOA days, we would have use choreography with an enterprise service bus to sort of attach up these services in order to get the answer back to the client. So what this really is a large set of orchestration steps, where we have the different services and we've got sort of databases and all of these sort of discrete steps that have to occur in order for the order to properly take. And so what's kind of key here with an event-driven architecture is that most of these applications are really essentially subscribing to events that they know that they really need to process, and then they're producing new events. So that really kind of shows up here in this architecture with these sort of not exactly squares, but kind of tilted squares, which kind of shows that when you go from microservice to microservice, these are just basically pieces of data that are flowing. And these pieces of data all basically end up implementing a service orchestration, but in a very, very loose way where there is no central orchestration manager. It's just each service is interested in particular pieces of data, consumes those data, and produces new pieces of data. So service orchestration is certainly a hot topic. We've gotten asked now multiple times about our views between orchestration and choreography. We're certainly on the orchestration bandwagon, and if you can make that orchestration occur as loosely as possible, that's incredibly useful. So I kind of want to then now dive into, if you were to take that initial picture where I said, okay, we have a much more streamlined architecture with deferred execution if we use event-driven processing, what we're able to now kind of do is take it on a use case by use case sort of basis and sort of call out the integration messaging styles that we were able to use in order to facilitate these different behaviors and these sort of orchestration pieces. So when we started out here, the customer needing beer hit the web application, and he could publish a JMS message over a topic with a reply to queue with the actual order as the message. And so in the case of Solace, which is the messaging platform that we are using since we are Solace, and of course, we have to, as I mentioned before, eat our own dog food. Solace has a great capability of being able to publish on topics and consuming off of queues, where the queues can actually subscribe to topics. So in this particular case, we're interested in order initiation, and specifically that's what the inventory manager is interested in. So he consumes to this queue, and he gets the benefit of basically round-robin load balancing off of this non-exclusive queue. So for instance, the first order would come in maybe to the first event manager A, event manager B would get the second, et cetera. So right there you have horizontal scalability of your inventory manager, which is great. He's ultimately going to write or reserve a product in the inventory database, and so certainly we want to ensure that ideally that the inventory manager is idempotent, so that if for some reason there's a problem and you ended up with a duplicate message, that ultimately the state would remain the same. So ultimately, he's then going to do two things. He's going to send out a new event saying that there's an order that's been reserved, sending that across the order/reserve topic, and he's going to send a message on the reply to queue with the order response, which would typically, of course, say that the order's in process and the consumer gets his answer. So in order for the consumer, again, to get the result, this is the only interaction that really has to happen. Everything else kind of keys off of that line labeled 4, where we send out the event across a topic just saying the order's been reserved for order number 112, and the zip code is 84020. So, and you'll see why we would actually use something like the metadata aspect of a zip code here downstream a little bit. So the next step in the architecture would be we want to quickly make sure that the consumer has the funds available to support the interaction. So we would have a billing service here. He would be ultimately interested in consuming to the billing orders queue, which is subscribed to that order reserved event. So when that event gets fired off, it would then be attracted into this queue. It would again be round robin load balanced into the billing service, where the billing service would then call the credit agency, which of course is external to our system unless we're providing credit cards as well. And so again, basically using transactions here is probably required. You would hate to charge the guy's credit card multiple times. And then you would basically fire back a new event saying either with the topic of billing / either paid or no funds, depending on whether that credit card transaction was successful, and again, the order number and zip code, and attach any of the metadata in addition related to billing onto the message. And so where you can actually see here how compensating logic could easily be added is if we have a no funds queue that's subscribed to billing / no funds greater than, and these greater than, by the way, is essentially the Solace mechanism of doing wildcarding, right? So this is basically, if you're thinking regular expressions, this is like, the greater than is kind of like the star or asterisk symbol of anything after this dash will ultimately match and end up in this queue. From there, we have the inventory manager that we could say has the responsibility. It doesn't have to be the inventory manager, it can even be something else. It could be the customer service function. Regardless, it could receive the message unreserved from the inventory database and send out an email to the customer saying that there was an issue with your order, your credit card was declined, please resubmit your order. So that's a great example of having compensating logic in your system, as well as having eventual consistency. So for the period where billing had denied the credit charge to the time in which the inventory manager releases the product, we're actually in a bit of an inconsistent state. But eventually, the inventory manager will unreserve that entry in the database, and then we will become consistent. So anyway, good example, I believe, of eventual consistency. So next up is going back down the happy path of we got paid. We have another queue here called the IM funds queue, which is basically, again, another inventory manager component that would take that. It would actually, instead of just reserving the product in the database, it would switch that product to officially be in the state of processed, essentially, and it would then send out a mechanism that says it's ready to ship. In fact, I was looking at this last night and realized that the topic probably shouldn't be ship here. It should probably be order slash, processed or inventory processed, because here again, it's really an easy thing to do, but it has ramifications down the road of, I'm making an assumption here in the inventory manager that the next step is ship, and that may not necessarily be the case. Of course, it is in this particular scenario. So again, we've got another queue that's subscribed to the order ship greater than topic. So all sort of messages that match that are going to end up in this queue, where logistics is actually going to pick this message up. It's going to say, okay, I need to find a vehicle so that ultimately is willing to process and do the last mile delivery for this beer order. So it's going to send out a message on a logistics / locate V order number and zip code, providing again the message and putting in an attribute of a reply to queue so that it can get responses back. So that gets fired out over a topic where these vehicles are just consuming onto the topic, just kind of like when you're in Uber and you're watching an Uber driver, where he's getting these events coming in of a person wanting a ride, and they're able to click accept or deny. That's essentially the same paradigm we have with our delivery system and this reference architecture. So all the vehicles that are within the 84 zip code, and that's where we're able to use that attribute. So all vehicles in that zip code would ultimately receive this message, and then they have the ability to accept or deny. So in this case, we end up with 2 accepts and a deny coming back onto that reply to queue, the CDE 456. And so then ultimately, the logistics manager, all it really needs to do is browse this queue, pop the queue essentially, until it sees a message of accept, which in this case could either be the first one or the last one, depending on the order you're reading that in. And then it knows that basically that car is the ultimate car that's going to make the delivery. So that shows actually in this case a request and multi-response, all such that the logistics, it doesn't have to know the address of any of these cars. It's just able to send out a topic notification saying, hey, I need to locate a vehicle. Here's some metadata, here's a reply to queue, and it really allows the vehicles to sort of say what they're interested in based off of their zip code. And you really don't have the sort of discovery issues that we would have had if this was all just a synchronous sort of interaction style. So remember, one of the premise aspects of our initial use case was that the customer, he wants to be able to track the vehicle's location as it moves around the city so that he knows exactly where his beer is. I think this would be probably a really bad idea in real life. This vehicle would potentially be the most robbed vehicle ever, but regardless, let's stick with the use case here where the customer could go to our web application, and he wants to basically kind of like on a Google Maps type of a screen, live stream the location of this vehicle. And that's really easy with publish and subscribe, of course, because the car, even without a delivery, could be producing a message that actually has his location. And all that the web app really has to do is know which vehicle has the order, which is really not a challenge because of sort of the way we were doing topics and what's actually as part of the pieces of data events. And so essentially, as this car is producing those lat-long coordinates that we could map in Google Maps, those can stream right into the web application, into the client's browser by using, for instance, WebSockets, so that you do ultimately get a true live stream of exactly where that vehicle is. So that kind of, again, provides that Uber feel where you're waiting for a ride and you can kind of see the driver moving around. That's kind of what I had envisioned for the customer wanting his order, being able to see the vehicle. And again, it's very sort of simply implemented if you're able to make use of the publish and subscribe message exchange pattern. So to kind of conclude this overall, I kind of wanted to synthesize this data down into a chart that I felt would be sort of eye-catching and kind of prove the point here that if you take event-driven microservices and you combine it with messaging, you have a lot of benefits such as, the ability to do deferred execution, which we showed, burst absorption, fault tolerance, the ability to do the fine-grained service-by-service horizontal scaling, the ability to minimize service coupling, and to have service performance management be very, very seamless because you could just monitor, for instance, queue depth and see where we're getting behind in the system, provide additional services. It all is interleaved by having all of those kind of functions together. And so what's really feeding those benefits, though, are these patterns that we're able to make use of because of the asynchronous nature that messaging is really providing. Whereas if you just have microservices and you want to stick with REST, then your benefits are you end up really doing, you can do horizontal scaling, but in a lot of cases it's going to be what I call coarse horizontal scaling. And what I mean by that is that if really the third service, if you think of this kind of as a linear invocation list, right, and you have service A calling service B calling service C, if service C is the bottleneck, in order to really compensate for that, you really actually have to scale service A, B, and C because A and B are actually just being blocked a lot of the time by C. So that's what I'm meaning by coarse horizontal scaling, whereas in an event-driven architecture, you could just scale up C in order to meet the load without having to scale A and B. So I think that's really good. And of course, the benefits of REST are certainly public-facing APIs. From a Solace perspective, we implement, of course, we're a messaging provider, but we also have REST as a supported protocol. So, we certainly aren't down on REST by any stretch of the imagination. What we really are down on, however, is if you have microservices calling other microservices directly and having that tight coupling, that's certainly a big challenge. So, and again, the fact that this red circle is sort of has very few benefits is largely just due to only being able to make use of a synchronous request reply and the fact that a lot of organizations implement this in a very sort of coupled sort of way. So that is the material that I ultimately had for this presentation. Hopefully you guys take something out of this and can apply it in your own companies or industries. And what we're going to be doing here going forward is just like how in May we had why is REST sort of not the end-all be-all for communication between microservices. Now we kind of looked at it in a deeper level from a architecture, design pattern, message exchange pattern sort of way. Our next webinar that we'll be having is going to take the Sol Beer Store design architecture, and we're actually going to implement that using Spring Boot. So we're going to write all of our microservices in Spring Boot. We're going to use the Solace messaging virtual message router to act as the messaging platform for this little mini enterprise. And we're actually going to run this all within Pivotal Cloud Foundry to sort of show how Pivotal adds the capability of easy deployment, easy scalability of your microservices. It really provides a lot of value adds to the architecture. Solace would be, like I said, providing the guaranteed reliable messaging along with low latency for this. And we're going to actually build up this architecture and provide the actual lessons learned as we actually went through and took it from paper and made it into a real implementation. So yeah, that kind of concludes my talk today.
Thanks, Jonathan. We do have one question from the audience here. What messaging platform do you use in real projects? I think you kind of answered that in the last discussion here, but if you'd like to repeat that, that would be great.
Sure, yeah. So, kind of goes without saying that Solace is a messaging platform vendor. We provide hardware appliances that are really best of breed in industry. We also have a virtual message router that can be deployed pretty much on any operating system. It's available as a Docker container. We have a tile for Pivotal Cloud Foundry. We're in beta with being able to run that within OpenShift. So that's the platform, of course, that we champion here at Solace, and have found that we've actually switched a good number of customers away from other messaging platforms such as ActiveMQ or RabbitMQ or TIBCO, et cetera, onto using Solace as part of their digital transformation use cases and helping them with their microservices event-driven architectures.
Thanks, Jonathan. As always, your deep dives into microservices are fascinating and informative. I always come off learning something new every single time, and honestly, looking forward to the deep dive into an actual implementation of Solvier, something near and dear to any company's heart here, at least in my neck of the woods, the Silicon Valley. With that, we'd like to thank you also for attending today, and we look forward to seeing you next time on one of our webinars, particularly coming up with Jonathan on Solvier and implementation strategies. Thanks, and have a great day.